negative 5x plus 1. So let's subtract the 1 from each side, and we have negative 5x is less than or equal to negative 1. Now we need to divide both sides by that negative 5. Oh, tricky, tricky! Anytime you divide or multiply an inequality by a negative number, you need to switch the inequality sign. So right now it's less than or equal to. We need to switch it to greater than or equal to. And over here, negative 1 divided by negative 5, that's positive 1/5, which is 0.2, if you'd prefer a decimal there. So let's add the word or here. We need to graph this and this on a number line. Okay. Negative 3, let's put that right here. It says x is greater than or equal to negative 3. Greater than or equal to negative 3 would be right here, like that. Now this one, x is greater than or equal to 1/5. So here's 1/5. This would be like that. Now something interesting happens here. Since all numbers that are greater than 1/5 are also greater than negative 1/3, this second piece of information becomes redundant. It's not needed. It doesn't add to what the solution of x is. So what we can do is simplify our graph as just x is greater than negative 3. Greater than or equal to. Oh my goodness. That means this dot has to be solid. If it was simply greater than, it could be an open dot. And these should be solid as well. There we go. All right, let's look at the next one. On number 10, I see a few things. First, it's an absolute value problem. And our first step in absolute value problems should be to isolate the absolute value. So we're going to try to isolate that absolute value. The second thing I notice is since x is both inside the absolute values and it's outside, there's a potential here for extraneous solutions. So at the end of this problem, we should check and make sure we don't have any extraneous solutions. So back to isolating the absolute value. The only thing on the same side of the equation as the absolute value is this 1. So let's subtract that out of there first. And we're left with 10 minus, or the absolute value of 10 minus 3x is x plus 4. The absolute value is now isolated. So now we can do the second step, which is to split the absolute value equation into two equations. Okay. So 10 minus 3x equals x plus 4. That's our first equation. And the other equation has to be 10 minus 3x equals the opposite of x plus 4. And make sure you put these parentheses. You don't want to make only the x opposite. You want to make that entire side of the equation opposite. Now, let's start solving these. This first one, I would subtract x from both sides. And move this 10 over. Okay. And finally divide both sides by negative 4. So it looks like x equals 3 over 2, or 1.5, if you prefer decimals. All right, let's look at this one. If we distribute this negative, remember this negative is like having a negative 1 out here. So it's negative 1 times x and negative 1 times 4. So that would give us negative x minus 4 when we distribute the negative 1 that's outside there. Now, let's move all the x's to the same side. This time I'm going to add 3x to both sides. And move that 4 over, so add 4 to both sides, since it's currently being subtracted. and divide both sides by 2. And we get x equals 7. Okay, we have two potential solutions here. They might both work, or maybe only one of them works. Let's see. When you check the solution, this is very important. Check solutions in the original equation. Don't check this 7 in this equation, or this in this equation. You have to go all the way back to the original equation, right up here, and check your solutions. So let's check the 3/2. So I'm going to write check 3/2. And let's see what happens. So I substitute in 3/2 everywhere I see an x, which is in 2 spots. And let's see if it works. Okay. -3 times 3/2 would be -9/2. And I'm going to write 10 in terms of halves. This would be 20/2 minus 9/2. This is still the number 10, just written as 20/2 plus 1. So the absolute value of that plus 1, does that equal 3/2 plus, and I'm going to write this in terms of halves too, it'd be 10/2. You know what? Let's write this as halves too. 2/2. Now everything's a half. Okay, 20/2 minus 9/2 is 11/2. The absolute value of 11/2 is still 11/2. Over here, 3/2 plus 10/2 would be 13/2. And since 11/2 plus, since 11/2 plus 2/2 is 13/2, that solution checks out. 3/2 works. Let's check the other solution. Let's check if 7 works. It will certainly be easier to plug in than 3/2. Okay, back to the original equation. Everywhere I see an x, I'm plugging in a 7, substituting in a 7. Okay. 3 times 7 is 21, so 10 minus 21 would be -11. -11, the absolute value of -11 is 11. And 11 plus 1 is 12, and so is 7 plus 5, so that checks out. These are both solutions. So no extraneous solutions this time. Those are your two solutions, and you're done with that problem. All right, a few more. Number 11. Solve for r. Ooh, there's r. It's really buried in this formula here, this equation. So let's see. All of this stuff here, this 2, the t, the -36, and the k, those are all on the same side of the equation as r. We need to get rid of all of those pieces. The easiest one, and the one we should start with, is this k. K is dividing out from r right now. So to undivide, we need to multiply both sides by k. So multiply this side by k, and this side by k. So d times k would be dk. The k's are going to cancel, and we're just left with 2rt minus 36. The next thing we should target is that minus 36. To unminus 36, let's add 36 to both sides. So we get dk plus 36 equals 2rt. Now, we still have a 2 and a t, and the 2 and the t are both multiplying by r. Oh, sometimes it's helpful to every step go back to the directions. We're trying to solve for r. So don't get bogged down on the left side of the equation or really what's going on here. Just keep focusing on where's r, is it all by itself? And if it's not, can I get it more by itself? So right now, r is not by itself. The 2 and the t are multiplying with r. So to unmultiply, we would divide by the 2 and the t. And that does it, because the 2's are going to cancel and the t's are going to cancel. We get r equals dk plus 36 all over 2t. We have now solved that equation for r. All right, last problem, and maybe the most fun. Okay, at an all you can eat restaurant. They charge $10 for one person, but they offer a discount if you show up in a group. And the discount rates are as follows: 19 for 2 people, 27 for 3 people, 34 for 4 people, and so on. If it costs the restaurant $5.30 to feed each person, how many people in a group can the restaurant continue the discount for and still make money? Okay, your first reaction here might be to skip this problem, but you have to try something. So maybe the first thing we could try is just figure out what's going on with this discount. Well, how's this happening? I see for one person it's $10. For 2 people it's 19. For 3 people, 27. I mean, if there's a pattern here, that would help a lot. So let's see. To get from 10 to 19, it's a plus 9. So it's like $9 for the second person. To get from 19 to 27, that's a plus 8. Ooh, okay. So the third person who gets in there, they get in for an additional $8. From 27 to 34, that's a plus 7. Oh, okay. Plus 9, plus 8, plus 7. I think we found the pattern. Plus 6, so 34 plus 6 would be 40. Plus 5 would get us to 45. Plus 4 would get us to 49. Plus 3, 52. Plus 2, 54. Plus 1, 55. Hey, after that, it'd be plus 0. So I guess the next person's $55 as well. Maybe we should stop there. I mean, at a certain point, these are going to be negative numbers, and if you had a large enough group, in theory, the restaurant would be free, which would be fun to talk to the restaurant about, but I'm sure they've thought about that, and they have a policy in place to protect against that. Now that we found the pattern, the discount pattern here, let's figure out what this whole $5.30 thing is. Okay, it's an average of $5.30 to feed each person. That's the restaurant's cost. So like if only one person goes in, they pay $10 and it only costs the restaurant $5.30 to feed them. So the restaurant would be getting $4.70 profit. Now for 19, they would have a different profit. They would collect $19, but they would spend $10.60 to feed those people. So I guess that would be an $8.40 profit for those 2 people. But it would still be profit. So our question is, how many people can a group be and the restaurant still make money? Okay, I think I would arrange this stuff in a table. Let's see, group size, 1. Price. This is going to be the total price for everyone to get in. And then the average price. How much is the restaurant getting per person in that group on average? Okay, group size, if it's one person, it's $10. We already found that. So the average price would be 10. How many did we get here? A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Now, I don't really need to fill out this whole table. I'm trying to find where's the cutoff? When does the average price drop below $5.30? Because that would represent when the restaurant's losing money. Maybe I'll jump to like the 7th. A group size of 7 here. So let's see. 1, 2, 3, 4, 5, 6, 7. So if 7 people go into the restaurant would collect $49 from those 7 people. Oh, we lucked out. That means the average person in that group of 7, since the total was $49, is paying $7. Since that $7 is higher than $5.30, the restaurant is still making $1.70 per person. So they're still making money. So 7 is an acceptable group size from the restaurant's perspective. Let's jump to 10. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, at 10 people, the restaurant would collect $55. 55 divided by 10 is $5.50. average. By the way, you get to use calculators on the test, so you could, if you needed that, you could go 55 divided by 10, 5.5. Okay, restaurant still making money. Let's look at 11 people. Now for 11 people, strangely, it was the same price because the pattern was still plus 0 there. So they would still charge $55 if the restaurant kept their word and followed their pattern here. 55 divided by 11 is $5. Huh. Okay, at $5 per person, the restaurant is losing 30 cents per person. So this is where the cutoff is. The restaurant makes the most money per person with a group size of 1. So I'm sure lower group sizes is nice from the restaurant's perspective. But right here, if we get to a group size of 11, the restaurant loses money. So the question was, how many people in a group can a restaurant continue the discount for and still make money? Well, 10. At 10 people in the